Welcome. My name is Claudio Micelli from the Federal University of Rio de Janeiro, and I'm pleased to invite Professor Giancarlo Fortino for one of the PESC seminars. Professor Giancarlo Fortino is a famous researcher worldwide on the IoT topic. I've known Giancarlo for more than 10 years. I'm not that old, but we have known each other for more than 10 years, and it has been a really pleasure to have him here. Professor Giancarlo, as is in his CV, he's a very distinguished professor with working from the University of Calabria, but in several other universities, such as the Berkeley and Queensland University and several universities in China. He is one of the first professors well-known worldwide that has positions in prestigious Chinese universities as Tsinghua. So, as his curriculum show, he has hundreds of publications and formed great students worldwide and has formed a lot of groups. So it's a big pleasure to receive you here. Please, Giancarlo, welcome to the Federal University of Rio de Janeiro. Thank you very much.
Okay. Thank you. Thank you very much. Thank you. First of all, I'd like to say that I'm pretty glad to be here. Yeah, there is some echo. I can go? I can hear my voice. I can hear my voice.
It's another computer. Can you mute? You're able to mute it from here?
Yeah. It's here. It's more. It's here. It's
here.
Oh, okay.
Okay. It works? Okay, great. So, first of all, I'd like to thank you, for your hospitality. A lot of friends, Jano and Claudio, we know each other since a long time, okay? Since a long time in different contexts. Computer-supported cooperative work in design, the conference at the TC launched by Wei-Ming Shen, but also multiple conferences launched by Flavia and Paolo, okay, and Claudio too. Okay, so, yeah, I'm very glad to be here. I have to say that my grandmother was born in Brazil, in Itajubá. Many. She's died, unfortunately, many years ago, but she was born here, in Itajubá, and at 3 years old, she moved back to Italy. So it's always, yeah, was my very pleasure, to stay in the country where my grandmother, was born. Okay. Let me see. Okay. Yeah, it works. Okay, so today I will give you a distinguished lecture, because this lecture was supported by System and Cybernetic Society, IEEE, in order to disseminate results, but not only research, in the context of this important society. SMC is one of the oldest society in IEEE, and the focus of my talk is related to generative digital twins. So it's pretty broad, that I'm sure it could be applied to all of your, research areas. Okay, so I hope that we can, interact even after my talk. Okay, I just introduced my laboratory to you, named the SPEME laboratory. SPEME is an Italian word, means hope, okay? But the acronym is Smart, Pervasive and Mobile Systems Engineering. Currently, my research group is a huge research group in Italy, more than 40 people. I'm honored, to coordinate so many people. So, associate professor, assistant professor, postdocs, and PhD students.
No, it's okay.
Okay. let's hope for the best.
Everyone outside of us I see really
Okay. So, yeah, people coming from all over the world, as you may see here, of course from Italy, but also from India, Colombia, China, Pakistan, Bangladesh, Romania, South America, so Colombia, South America. We also had a PhD student from your university, Evandro Macedo. Yeah. Unfortunately, he was at my university during the pandemic period, unfortunately. But anyway, he was there for 6 months, more or less. Currently, we manage a lot of projects, almost 10 million euros projects, and many international collaborations, South America, you know, okay, with all of you, okay, from Brazil. Just to let you know, my guys, okay, many different faces, our seniors, and a lot of PhD students. Claudio, if you can take some picture.
Of course.
Okay, this is the outline of my lecture. First of all, I'd like to share my vision of edge intelligence. Then I will briefly speak about our European project named PESC-COPPE. It's a 7 million euros project involving multiple partners. And then I will focus on digital twins, okay? Okay, let's start from Internet of Things. Let's start from this definition that I'm used to provide, very different with respect to, the mainstream definition, because usually the mainstream definition is based on the concept of network. So, Internet of Things is a planetary networks of multiple objects, things, embedded computers, sensors, and so on and so forth, that are able to communicate using standard communication protocol. I don't like this definition, because in my opinion, IoT is not a network. IoT is a huge ecosystem, will be a huge ecosystem. So, my definition of Internet of Things is much more oriented to multi-agent systems than to networks, okay? And this is the definition I'm usually provide, a loosely coupled decentralized system of cooperating smart objects, where cooperating smart objects are agents. So at the end of the day, Internet of Things is a multi-agent system, okay? So this is something that I'm trying to promote in my papers, in my research. What's the current status of Internet of Things? We are in the next generation wave. The very first one was many years ago, 1997, 1999. I was in Berkeley at the time, and it was the very first inception of wireless sensor networks. There was the Smart Dust project launched by UCB, and also the term Internet of Things was coined by Ashton in 1999 at the MIT, okay? But now we are in the new wave of Internet of Things that is mainly strongly driven by artificial intelligence, okay? So artificial intelligence is fundamental for the next generation Internet of Things. As you may see over there, there is an increase about 20% of the market, of the global IoT market, okay? So this is expected even for the next couple of years. It means that there is still a lot of attention to Internet of Things services, Internet of Things hardware, Internet of Things security, and so on and so forth. Okay? Let's discuss about numbers. Currently, we have connected to the Internet about 150 billions devices. Okay? 150 billions devices. It is expected that by 2050, we will have trillions of devices connected to the Internet. Okay? The market is a huge one, $1 trillion market, okay, that was pretty resilient to COVID-19. Indeed, you know, specifically wearables were able, you know, to push the market because people, in order to be monitored, they bought wearables, okay? So this resilience was also due to the introduction of new wearables. And another important aspect is investment in enabling technology like 5G, Wi-Fi 6, augmented reality, and so on and so forth. I don't know the status of 5G in Brazil, but in Italy it's not so good. It's good? It's good? Okay. In Italy it's not so good. Anyway, what's the final goal? The final goal is to create this IoT ecosystem where human and machine could interact with each other, okay, and provide services. So the real drivers of Internet of Things are services, okay? So this is, you know, the main goal, to create services, okay? Okay, as I told you, we have more than 150 billion connected devices, and such devices are able to generate data. Currently, more than 90 zettabytes of data. So we cannot bring such data onto the cloud. We need to start analyzing such data. We need to start executing AI algorithms as soon as we collect data, okay? So this is the concept of edge computing, okay? Let's move computation rather than data, okay? Let's move computation rather than data. So this is an already well-established concept, and we already have some de facto standard architecture, like you know, the one on this slide. So you have the device layer that could be smart devices or even dumb devices, so the device layer. Then the edge layer with different typologies of computational nodes, edge node server, powerful ones or less powerful ones, but able to support different functionalities like data processing and reduction, data caching and buffering, even code offloading and data flooding, virtualization, okay? And of course, sometimes we also need the cloud, okay? We also need the cloud in order to have big data processing and data warehousing, okay? What are the benefits from, you know, this approach? Faster response times, so this is one of the most important benefit, but also improved reliability and enhanced data security. So these are the three main benefits deriving from edge computing. Of course, we need to deal with different issues like how to coordinate so many devices. So this is an issue, even a research challenge, and also how to assure data consistency. Data consistency cannot be, there is a theorem, you know, very well known in the literature, was a guy from UCB, data consistency cannot be assured in a planetary network, okay? So if we are on a best effort network, data consistency cannot be assured. So in this case, you know, we have to deploy different techniques in order to deal with such big problem. Another aspect that I'd like to integrate with edge computing is AI. You know that AI was not born 3 years ago. AI was born many years ago, almost 80 years ago, 70 years ago indeed, was 1955, so the term was coined by McCarthy 1955, so it's 70 years, okay? So we have a lot of techniques that we could exploit, apart from the generative ones, okay? A lot of techniques that we could exploit for planning, learning, and reasoning, okay? And we can integrate in the edge computing in order to have this new paradigm that we called edge intelligence. So this is the definition of edge intelligence from my perspective, a truly distributed and pervasive approach which allows for the processing and analysis of data as much as possible at the network and device layer, okay? So this is what we defined as let's say a definition of edge intelligence. Again, what are the benefits? The same ones we got for edge computing, but with something more provided by artificial intelligence. So you can see, you can provide decision making at the edge. You can have more operational efficiency. You can, of course, reduce costs, latency, and data traffic. And another important aspect is privacy. Think about federated learning, for example, and more scalability and reliability. In order to understand much more about edge intelligence, we performed this meta survey. I strongly advise you to download this paper, an open access paper, okay? I will not go into details, but again, we use the Prisma methodology in order to have this survey and try to understand the status of edge intelligence, the current status of edge intelligence. So this is the overall framework. You see the edge intelligence concept in the middle, and then we have definitions that could be revolutionary or evolutionary, but also different topics and techniques, and even different architecture. For example, if you consider the techniques, you have multiple edge-catching computation offloading. There are a lot of papers providing computation offloading, but also a lot of papers in the context of building models, tiny models, okay, tiny models at the edge. Tiny models referring to deep neural networks, or anyway, machine learning models, again, developed at the edge, okay? Not developed on the cloud and then injected at the edge, developed directly at the edge. Okay, some lessons learned about, our exploration of edge intelligence. First of all, let me just Okay, so The first point is that IoT systems and the services we are going to build atop such kind of IoT systems need to have intelligence, okay, to unleash their potential. So injecting intelligence in IoT system is fundamental, okay, for the next generation IoT systems. Edge intelligence is already a well-established field, not only a research field, but also an industry field. There are a lot of experiences in exploiting edge intelligence even in non-research environments, specifically in industry environments. And even at the standardization level, you know, HC is a standard body for telecommunication. If you consider the HC MAC stands for Mobile Edge Computing, AI, edge intelligence, is being introduced inside such kind of gateways that are already deployed, okay, by telco operators. Okay, for example, in Italy, TIM deployed such kind of gateways, Huawei in China, and so on and so forth. So again, edge intelligence is being, you know, used even in industry or real environments. Another important concept is edge cloud continuum. I will focus on this concept in a little while. Edge intelligence could support such new architecture, named the device edge cloud continuum, so that the management of this architecture could provide more efficiency and effectiveness to the applications that are developed atop such architecture. And this is, you know, the abstract concept of device edge cloud continuum, in which you have the IoT layer. It means the device layer with multiple devices. They could be tiny ones or even large ones, smart or not. Then the edge, the network, and the cloud. Okay, so this is something that we need to treat again in a continuum way. So the borders between the layers should be made smoothed with respect to, you know, the current status of the technology. And again, this is another infrastructure in which you also got the fog, okay, instead of having the edge, even though, you know, differentiating fog and edge is not so it's not so easy. It's much more a matter of philosophy than technology. And again, the management of such kind of architecture need to be done in a very effective and efficient way. So this is why, you know, we submitted this project, and we got accepted this project named Machine Learning for Autonomic System Operation in the Heterogeneous Edge Cloud Continuum, MLC-SOPS. So this is the consortium. We are the deputy coordinator. The coordinator is University of Thessaly in Greece, but we also have many small, medium, and also large enterprises, like, you know, Entity Data and NVIDIA, as large enterprises are supporting our project. So what's the objective of this project? The objective was to try to create a management plane atop a, let's say, conventional device edge cloud infrastructure, a management plane able to manage computing, storage, networking resources in real time using the MAPE loop. Maybe you remember the MAPE was introduced by IBM many years ago, was the monitoring, analyzing, planning, and executing loop, always in the context of multi-agent systems. But we reused this concept of MAPE by coupling the MAPE loop with two key AI technologies. One is explainable AI, and the other one is continual learning. So we are able to collect data coming from the system, and according to the analysis and the plan, we are able to enforce specific policies in order to make the system more efficient. This is orthogonal with respect to the application. So we don't modify any application in order to have more efficiency. Okay. The implementation of the system is currently based on multi-agent systems. As you can see, the faces represent the different kinds of agents. So at the node level, at the infrastructure level, at the continuum level. So this is a kind of super peer infrastructure that is able to implement this MAPE loop integrated with AI technologies. Our proposal is being also tested according to different use cases. You see the use cases that we are developing. The first two use cases, smart agriculture, smart city, are being developed by small, medium enterprises, while the second ones, these ones, are being implemented at the laboratory level. Okay? But anyway, multiple use cases that could provide insights on the proposal at the architectural level that we are developing. Okay, now I will focus on the concept of digital twins. I'm sure that some of you is working on the concept of digital twin. Who of you, digital twins? Okay, I guess now digital twins are pretty hot. Okay, then we are trying to apply them everywhere. But anyway, the very first inception was due to Greaves and Hughes. Greaves, 2014, proposed a digital twin for manufacturing, while Hughes, 2018, proposed the very first model of digital twins. It was the mirroring model. Okay? So that is, the conventional definition of digital twins. A digital twin is an executable virtual model of a physical thing or system. Okay, so this is something that is already well established in the technical literature. Okay, so the components are the physical object, so in the real space, the logical object in the virtual space, then we have data flowing from the real space to the virtual one, and some feedback from the virtual space to the real one. Okay, so this is the classical mirroring model. Okay, let's do a step ahead, in the sense that an improvement on this basic model was proposed by us a couple of years ago in this paper, appeared in the ACM transaction sensor networks, and we call it such digital twins opportunistic digital twins that are edge intelligence powered digital twins, and such digital twins could opportunistically adapt to and act upon the physical environment that surrounds them. So it's a kind of definition of multi-agent systems again. Okay, so you can see this new type of digital twins as multi-agent systems. Okay, and what are they able to do? They go beyond the digital mirror, providing adaptive learning. This is an important characteristic, pattern detection, and predictive maintenance. So these 3 points are fundamental in order to enable new, let's say, applications, okay? New applications based on the concept of opportunistic digital twins. In order to demonstrate benefits deriving from this new paradigm, we implemented a real system named AI-based traffic monitoring system. This was developed with some colleagues from Telecom Sud Paris in Paris. What are the key features of this system? Based on technology based on edge intelligence, the exploitation of the concept of synthetic sensing. It means that we use the construction of models is based on a bottom-up approach. It means machine learning, instead of using a top-down approach. Okay, so this is the full architecture. So you can see, the IoT level. Okay, this is the IoT level. The objective was to detect vehicles in an intersection inside a smart city. And here we have different boards, less capable, more capable boards. Think about Google Dev Board, the Coral one got GPUs inside, so it could be used even for computer vision, okay, or for processing, data coming from video or images. Then the middleware layer is based on, again, conventional technologies like MQTT and Node-RED that are, quasi-standard in the IoT area. And also we have the cloud layer based on different, let's say, different components able to manage several aspects, okay, of data, of computation, and so on and so forth. This is just, you can see the hardware configuration and the software tools. So you can see that at the edge level, we use TensorFlow Lite, okay, that could run inside even tiny boards. Okay, just some consideration from the performance viewpoint. In this use case, our goal was to detect vehicles, and to detect vehicles, there are two parameters, important parameters that we have to take into account. The first one is accuracy, okay, and the second one is latency, okay, and these two parameters, we need to find trade-off, okay, because maybe you could have a lot of accuracy, but the latency is not so reduced, and vice versa, okay? So you have to find some trade-off experimentally. So we don't have any formula, we don't have any theorem. Experimentally, we have to find some trade-off. As you may see here, this is the latency. Of course, if we use less accurate models, latency decreases, okay? But of course, accuracy decreases too, okay? So we need to find a trade-off. For example, if we use the MTD model, provides an accuracy that is more than 85%, okay? That is a pretty good accuracy. But of course, the MTD model got more than 70 milliseconds of latency. It is good, it is not good. We need to understand. We need to understand if it is good, if it is not good. Okay, it depends on the system and on the requirements you got. Please.
How many vehicles? You're talking about how many vehicles?
How many vehicles?
One or several?
Yeah. This is vehicle per vehicle.
Okay, one by one.
Yeah, this is vehicle per vehicle, okay? Because in the intersection we got cameras, so it's vehicle per vehicle. Yeah. Okay, other consideration related to edge versus cloud. This is the configuration we use it. This is the edge configuration, this is the cloud configuration that is much more powerful than the edge. And it's important to say that if we exploit edge, we can reduce data traffic of 4 orders of magnitude. That is huge saving, it's a huge saving, okay? Instead of transmitting 3.3 terabyte, we can transmit less than 1 gigabyte. Okay, so this is something that anyway we have to consider, and this, the motto, you know, the motto, moving computation rather than data is fundamental. It's fundamental nowadays, okay? Okay, let's move, you know, to the end of my lecture. I'd like to focus on this new term that we coined recently, generative digital twins. And you can see, you know, the evolution of digital twins. First of all, we had the mirror world, then the concept of digital twin, then AI-driven concept of digital twins. For example, the opportunistic one we introduced, but not only. Now, 2022 on, we got this concept of generative digital twins with the introduction of generative AI. Okay? So, that is a definition of generative digital twins. Novel approach which seamlessly merges classical digital twin model-driven system with generative AI, creating a dynamically shaped system with exceptional adaptability. So the main goal is to have adaptability of our generative digital twins. Adaptability from which perspectives? Different perspectives. The first one is related to data. Sometimes we don't have data. Often we don't have data. Or if we got data, data are incomplete, are faulty. And then if we try to take decision based on incomplete data, faulty data, our decision could be wrong, okay? Or could be misleading, okay? Generative AI could provide us tools, techniques, able to support us to reconstruct real data. Much better than statistics, okay, much better, okay? Because sometimes, and I would say often, statistical models are not able to capture the reality. Okay, that's a main issue. That's a main issue. Another important aspect is facilitating digital twin IoT device, let's say, human-machine interaction. Okay, think about LLMs, okay, large language models. Okay, so this is another important aspect. Okay, this table is very interesting because it's a comparative analysis of traditional digital twin properties with next generation generative digital twin properties. The properties we took into account are these 5: adaptability, real-time modeling, data quality, data generation and augmentation, interaction with physical assets and human operators, simulation. If we consider generative digital twins, such properties are much better addressed with respect, you know, to the classical digital twins. In my opinion, the most important aspect is the capability of generative digital twins to generate, even on the fly, data. Okay, to generate even on the fly data keeping the data generated much more realistic with respect to statistical models. Okay, so this is something that we are exploring in our research. So, what are the architecture that are mainly used in the state of the art? Mainly three architecture: variational autoencoders, generative adversarial networks, and transformers. Okay, these are the most used ones. The first one is very good for learning complex data distribution, detecting anomalies. GANs are very good when, we got replicating intricate patterns typical of physical systems. So if we deal with IoT, cyber-physical systems, GANs could be very useful. And transformers that are the basic components underlying the large language models. And they work not only for text or images or video. They work well also for IoT data. Okay, also for IoT data. What's going on? Okay, great. Okay, this is a use case we developed based on this concept of generative digital twins. Okay, we presented this research recently, end of last year, in the World Forum, IoT World Forum of IEEE. Again, we are in the same context as the previous use case, smart city, and specifically in a smart intersection. In this case, we don't want to detect vehicles, okay, but we'd like to predict trajectories, okay? We'd like to predict trajectories of vehicles in the intersection, okay? It's very difficult. It's very difficult because there are techniques that work pretty well in freeways, where the trajectories are more or less rectilinear, okay? But in an intersection, usually trajectories are curved, okay? So it's very tough, to predict them. But prediction of trajectories could help avoiding accidents, okay? Could allow traffic optimization, and also optimal traffic assignment. What's the state of the art? As I told you, different techniques, mainly working for freeways, okay, not for intersections, that are mainly based on LSTM. Okay, LSTM is a quasi-standard, for such kind of objectives. We introduced a new architecture that is a generative architecture, able to deal with partial data, okay, not just with the assumption that we got all the data. No. This assumption is not realistic, okay? We need to deal with, partial data, because sometimes we got 10% of corrupted data, 20% of corrupted data, 30% of corrupted data, and we have to deal with such cases, okay? So we started from, this intersection that is a typical one very famous one, is intersection in Tokyo, Japan. And we have the video of this intersection. And from the video, by applying the YOLO tool, we were able, to have our data set, okay? Our data set means vehicles, all the vehicles, and the trajectories of the vehicles going through this intersection, okay? So you can see over there that from the smart camera, we can apply YOLO, and then we can have the data. Are data corrupted? Usually, yes. Okay, so think about, one vehicle here, this is the camera, so you got a vehicle here and another vehicle behind the first one, okay? You are not going to grab it, okay? So you will miss data related to this second vehicle, okay? Anyway, in a real setting, you don't have 100% of data, okay? You got less than 100% of data.
So how do you differentiate between corrupted data and missing data? Because there are techniques.
In this case are the same.
Okay.
In this case are the same. We don't differentiate. Corrupted means missing or corrupted. Okay? It means that we have to regenerate the data anyway. Even if they are corrupted, we have to regenerate. If they are missing, we have to generate them. The same. Okay, so we use the Roberta component, that is a very well-known component based on generative AI, in order to reconstruct data, okay? To reconstruct data. And then we apply LSTM component in order to predict vehicle trajectories. Okay, I will just comment briefly some results. Okay, these are results obtained on not corrupted data, okay? You see that the LSTM ground recursive is got more performances than the second one. So we T1, T2, T3, T4, T5, it means that are the future times, okay? So T1 is the current time, T2 is 1 time ahead, 2 times ahead, 3 times ahead, 4 times ahead, okay? This is the prediction times, okay? Of course, at T1, you got the maximum accuracy that is more than 85%, okay? Of course, after 5 times, you have the worst performance.
So this LSTM model is able to see the immediate future.
Yeah.
The immediate future, not the
Yeah.
future.
This is the. These are the instant in time in future. T2, T3, T4, because the objective is to provide predictions. Okay? But what I'd like to show is the following. If you consider, LSTM with ground data, that is the red line over there, the accuracy, here you got the accuracy with corrupted or missing video frames, 20%, 30%, 40%. If you don't use the data reconstruction, okay, these are the performances in orange. They are very low performances. But if you reconstruct, performances will improve. Notably, okay? 37%, 68%, 92%, notably, okay? So the exploitation of the Roberta architecture is very beneficial for, the accuracy, the overall accuracy of the system. Okay. Okay. Let's try to, summarize with some remarks. First of all, the concept of device edge cloud continuum is becoming a best practice right now, not only in the research area but also in the industry. Okay, a lot of telco operators, but also companies focusing on edge and IoT are using this concept of device edge cloud continuum. Another important point is to push intelligence at the edge. So, machine learning algorithms, generative AI, and so on and so forth should be injected into the edge instead of waiting to bring data onto the cloud and then executing such algorithms. Because you can save, a lot of resources in injecting intelligence at the edge. Another important aspect is exploiting the concept of generative digital twins. The use case I showed you was related to a smart city, specifically to a smart intersection, but we are collaborating with other actors, other research groups. We are developing other use cases in different application domains, healthcare, smart manufacturing, robotics, and so on and so forth, in order to demonstrate the usefulness, okay, of this generative digital twin concept. Okay, pretty open for questions related to trust, security, and privacy. Not mentioned trust, security, and privacy in this presentation, but of course they are there. Okay, they are there. I gave a talk last year in PESC-COPPE 2024 about trust, security, and privacy. Publication possibilities. I'm the editor-in-chief of these two book series, Internet of Things by Springer and Human Machine Systems by IEEE Press Wiley. If you got ideas about a book project, please let me know, contact me, okay? No conference proceedings, okay? For Internet of Things, edited and authored books, also for IEEE Press Wiley, mainly authored but also edited books. Before finishing, I need to show you something related to SMC. Ask you to take a picture. Okay, yeah. Thank you. Okay, just some words about SMC, because SMC sponsored the distinguished lecture. You know that SMC, System and Cybernetic Society, is a global organization of technical professionals. It is split into three main areas: systems, humans, and cybernetics. Okay, so it's a very interdisciplinary society. Maybe it's the most interdisciplinary society with respect to the other IEEE societies. So you can see systems engineering, multiple topics, human-machine systems, multiple topics, our thesis in human-machine systems, cybernetics. Currently, I'm the Associate Vice President of Cybernetics. The president is Enrique Viedma. Okay, SMC is, okay, these are, the, the buzzwords: relevant, informative, authoritative, interdisciplinary, unique, okay? Believe me, SMC, in my opinion, is a very, very good society. I work with SMC since 2010. And it allowed me, to develop many things, okay? So this is something that, if you'd like, to join, or if we like to launch, the chapter, let's discuss about this, okay? Don't be scared, because it's very easy. It's very easy to yeah. young people. Claudio, you could be the one, But it's very easy, yeah, it's very easy. We support everything. And, we got a distinguished lecture program. The objective is, of course, promoting research areas of our society, help chapters, help creating new chapters. Brazil doesn't have any chapter on SMC, so we have to do it. We have to do it. And yeah, okay, these are some procedural, but I can skip this. And okay, thank you very much.
I know the time is already a bit late, but we have some small questions. A lot of people send regards. Professor Prof. Dedicato has sent you some
Okay.
regards. And there's some questions from the audience, both in here, you can ask, and both from the YouTube. From YouTube, does this data construction from generative AI serve to fill spaces of existing digital twins or to create entirely new twins?
Both, in the sense that the concept of generated digital twins includes a full creation of a digital twins using a bottom-up approach, or a partial creation, in the sense that you could already have a model based on some top-down approach, as in the classical digital twin approach, okay? And then you use the generative part in order to complement. So both, okay? You could use this approach, to create a new model or to complement an already existing one. Yeah.
Questions from the audience in here? Please, Professor John.
Yeah. I noticed that you did mention IOE, because I have been working with a postdoc and some students with IOE, because I think that in IoT environment, it's not the human being is not mentioned, it's not considered. So we think that's consider the human being
Yeah.
in the loop. It
Yeah.
would be interesting getting some nice results related to the flow of knowledge between man and machine, because in the traditional digital twin, the machine learns with the human, okay, but then it's out, so the human is discarded.
Yeah.
So I think you could have some better kind of interaction, so the human can learn from the machine as well, so you can have a flow going on to achieve a minimal control of the humans in the future. What do you think about it?
Yeah, definitely. I fully agree with you. In the generative digital twin concept, we strongly have these humans in the loop. This interaction between machines and humans. Okay, so this is something that is in the property you know, if you take a look here, you know, interaction with physical assets and human operators, okay, by using some LLMs technology, but not just LLMs, in order to have this, let's say, learning loop, okay, between humans and machines. So definitely is in the generative digital twins concept. So I fully agree with you, yeah. Because usually in IoT, you know, the humans in the loop are pretty limited. You know, the focus is much more on the network, on the things, okay, on the system, but humans are seen like, you know, just operators, but they are not in the loop. So the generative digital twin could put humans in the loop. So yeah.
Yeah, so thank you for your lecture. My question regards the projects you mentioned you would participate.
The European project?
Yeah, all
Okay,
projects.
MLC SOPs.
Yeah, not this one,
Okay.
only this one, but all of them.
Okay.
So how can the projects from other places like us generate valuable data sets, methods, and tools to be available to other universities? Like, how can you generate, like you said, you had the camera in Shibuya crossing. You said you generated a data set that has the trajectories of the vehicles, even with the corrupted data and all that. But you said, is this data set available and the methods you use? And is there a Git for it? That's my question, because when we're researching, there are many configurations, operational tools that we need to do in order to perform experiments in this area. And it's very important to have access to all of it and all that is being developed. And in my case, when I started with research, the first place I looked for was research with papers with code, the site, the website, because most of those papers, all of those papers have code linked to them, or data sets, or both, and it helps a lot when you see what they're saying in the text and what they are experimenting in real life with code, real code that you can replicate. And if it does replicate, if the text is missing some adjustments for the environment, then this is my question. So my question is regarding how do you see the expansion of this technology projects, the edge and intelligence projects worldwide, given that you can be a reference for them and you are a reference for them, giving your expertise and the data sets you generate and the tools you generate. That's my question.
Yeah, tough question in the sense that, of course, the scientific community is mainly based on papers, okay? So you got papers, you read papers, you take a look at the results, and so on and so forth. Of course, in this case, if you'd like to replicate, you know, experiments and so on and so forth, you need to have the data set, okay? But also, you know, the techniques, the algorithms, even tools that we use. In our case, if you contact us, we provide everything. We are used to provide everything, okay? No problem. Currently, it is not yet online, but usually we put everything online. For example, the SPINE project, that is another research area, is wearable computing system. It is an open source project since 2006, more than almost 20 years so far. So everything was online, all the algorithms, all the tools, and so on and so forth. Okay? So it's fundamental, you know, because otherwise, you know, yeah, it could be very nice to read the paper, to try to understand, but specifically papers based on machine learning, deep neural networks, generative AI, they need to provide, you know, the data set, they need to provide the tools. Okay, so if you are interested, please send me an email. I will provide you with, you know, the data set, with the tools we exploited. There is a PhD student of mine who is working on this, Fabrizio Mangione, and we are pretty available, you know, to provide everything. Okay? Yeah.
One last question? Okay.
I guess generative digital twins imply in more costs for running these models than traditional digital twins. And relating that with this edge intelligence in general, do you see a way for us to make use of generative digital twins and generative technologies also in a more affordable ways, like for countries in Brazil, universities in Brazil, or other universities and entities worldwide that may not have all the resources like to train a GPT model? Or
Yeah, interesting question. Interesting question. Yeah, take into account that we are not using LLMs. Okay, we are not using LLMs at all. Okay, so we are using generative techniques like, again, GANs, transformers, that are, you know, that could be executed even on your laptop. Okay, so you don't need a huge computational power. Okay, of course, if you would need LLMs, in that case, very likely it's more convenient to download some Llama or something like that, DeepSeek or something like that, and then fine-tuning, not creating it, because we are not able to create anything, you know, just huge elephants are able to create such kind of monsters. Okay, but specifically in this case, in this use case, the computational power we needed was just a laptop, a powerful laptop. Okay, so yeah.
So let's thank you, Professor Giancarlo, for his talk.
Thank you.
Giancarlo, it was a pleasure to receive
My pleasure, my pleasure.
On Wednesday, we have another seminar from Professor Gianna Sasaki from Azure. So hope to see you here, so to see you on YouTube. Don't forget to like and subscribe.